He broke worms down into 5 components. You don't need all these components to have a worm, but to have it be a good worm and a long-lasting worm, you should apply as many of these techniques as possible. So reconnaissance, your worm needs to be able to find other nodes to infect. So this is possible with cross-site scripting worms because it's kind of a passive reconnaissance. So if you infect a profile on MySpace and somebody comes to browse your profile, they're kind of coming to you. You're not really going to them. So whether or not it's real reconnaissance, we could debate, but the fact is we don't need it right now. So the attack component, we obviously have that. When somebody comes to view our page, we launch an attack against them. So that's taken care of. We'll give that a check. Communication. Nodes in the network must be able to communicate with each other. So one infected MySpace profile can't interact with another infected MySpace profile. There's no communication between them. You can't have HTML from one page talk to another, HTML from another page that, they have nothing to do with each other. They're not viewed in the same browser context. It's just not there, right? Browsers just can't talk to each other. Command and control. Command and control is what makes worms really useful. Just infecting a bunch of machines is cool, but to actually have financial gain, you have to make them do something. So there is an idea of command and control right now in some worms, in some cross-site scripting worms that we've seen, and it's all based on this centralized theory of include the evil page. So like if I infect you with a cross-site scripting worm, I force you to go to evil.com and download the latest copy of the worm. Well, there's a couple problems with that, right? So if my worm gets big enough, I'm going to DOS the site. I'm going to overload it. It's trivial to call somebody at the ISP or the registrar and say, "Do you need to take that down? That's being used to propagate a cross-site scripting worm." It's just too easy to beat. It's a single point of failure. So we're going to try to do something about that. So it is possible right now, today, but it's just unreliable. Intelligence, the worm network needs to know the location of the nodes and characteristics about them. So this is what some of the network worms did, but cross-site scripting worms, we don't really see that in any of the worms that we've analyzed. So doing a little bit of fuzzy voodoo math, we come up with maybe 3 out of 5. So is a cross-site scripting worm is a worm a real worm according to definition? Probably. So how cross-site scripting worms are different from the network worm? The infection model is different. So the first thing to say about that is, how is a worm different from a virus? So a worm self-propagates over the network, okay? But, I haven't thought this idea fully out yet, so, don't hold me to anything here. But I have this idea that we can create a cross-site scripting virus. Okay, so we're passing around rich data in Web 2.0 everywhere. Everywhere. And rich data actually isn't data. Rich data is code. An image tag is code that your browser executes. Most cross-site scripting worms that we've seen don't need to be cross-site scripting worms at all. They can be CSRF worms. Okay? So your browser's executing this rich data that we pass around willy-nilly. So I have this idea that we can have a self-contained cross-site scripting virus, right? Because that's what makes a virus different from a worm. It's like it's attached to a file, executes in whatever context it's given safely, and reliably. But we haven't really done a lot of research into this yet, just something promising. Okay, so the infection model for a cross-site scripting worm is actually different from what you think it is. So there's the poor innocent girl on MySpace. She makes a request to MySpace. She looks at, Sammy's infected profile. She gets a response. You might think that, okay, now she becomes a worm node. This is actually like an abstract thing that you took with the data and made it out to be. She is not actually part of the worm network. So really, it's just that, there's some number out of all the profiles on MySpace that are worm nodes. So really what happens is when she goes to MySpace, she gets some payload delivered to her. That payload issues, XML HTTP request back to the site. And the whole attack is taking place within MySpace. Okay, so now it was N, but now it's N+1. Okay, so N+1 out of the however many profiles are now worm nodes. So the worm is strictly on MySpace, has nothing to do with the users. We're not owning the users at all. Okay, so let's see if we can change that in the next generation. So it requires user interaction, okay, because the user needs to click on somebody's profile, right, or take some kind of action. So the worm is strictly contained with the web application. It's totally passive, totally localized. So no Warhol worms. Okay, so Warhol worm is a worm that's going to reach its maximum infection capacity in 15 minutes. So this was Andy Warhol's 15 minutes of fame thing. And one of the network worms did reach every machine it was going to reach in about that time. But we're not seeing that in the cross-site scripting worms. Orkut worm and the MySpace worm propagated very fast. Sammy had over 1 million friends in 18 hours. And that's a lot, but still 18 hours is a long time. Okay, the payload capability. The payload capability of a traditional network worm is any kind of malware that you want. Buffer overflow, format string, whatever, you can do any native code. Right? But at the application layer, things are a little different. We can perform any application function, right? So if God help us, if our banks introduce any kind of social network capability, then you can, thank you. Then they can, cross-site scripting worm could transfer money, could do all the kinds of things that you can do normally with a bank. JavaScript in the browser is game over as far as the application. Okay, XSS proxy / attack API. So like any of the XSS keyloggers or any of those kinds of cool things, like PDP's attack framework. So you can do that with the payload. So that's kind of like simulating malware. It's kind of like man in the proxy, or man in the browser, like Gunter was talking about. Totally JavaScript layer though. Or we can direct the user to malware, and then the things are really bad. I mean, really, malware is just such a game changer. With any cross-site scripting where you can install malware to their computer and you have no more restrictions. You're only limited by your imagination. So it seems kind of silly sometimes to think about cross-site scripting worms and think about JavaScript when you just have to redirect them to malware and then you can do whatever you want. But I'm hoping one day that we'll figure out that if we have ASLR and we have stack cookies and we have non-executable heap, non-executable stack, and we combine all those things together into one thing, then we won't have this malware problem anymore. Okay, so let's think past hopefully that 2 or 3 years in the future when we have all those defenses in place. So the target shift. So traditional worms, like Code Red would go after IIS server, and then it'll go after another IIS server, and it would jump from internet to internet. But when it landed on an internet site, it would actually do internal network address scanning so that it could actually hop behind your firewall, right? So this is not in a properly DMZ'd location, and we launch Code Red attack and attack something internal. Okay, so this technique is called island hopping. Okay, so we're hopping from an internet-facing island to a back island. So how are cross-site scripting worms different? Well, first of all, this is total ownage for an internet worm. Internet worm can go anywhere. And look at who we're going after. We're going after the servers. So lots of technical impact here, but not a whole lot of business impact. Okay, so how are things different for a cross-site scripting worm? So let's attach some names to these machines. So there's MySpace over there. MySpace has been hit with a cross-site scripting worm. LinkedIn, Facebook, some other social networks. So if we infect a user,